Dope. Yeah.
Yeah. Okay, what is happening? HSS from the 403 to the HAZ. Nelson. Okay, so we're learning about sinusoidal waves. And what is a sinusoidal wave? It's just a wave that oscillates between a maximum and a minimum around the center point. Comme ça. And the two waves we're looking at right now are sine, the value of sine of x, so going from a period of, well, basically an infinite period, but one full cycle for sine, oh no, it's the corona, just kidding, goes from 0, starts at 0, so when x is equal to 0, sine of 0 is 0. And it goes there, it hits a max when we hit the top of our circle at 1, or at pi over 2, so this is pi over 2. It goes back to 0 when we come down the other side of the circle to pi, and basically a full rotation goes from 0 to 1 to 0 to -1 back to 0 on the y scale, and that takes a period of 2 pi. Our baseline period for both y and cos is 2 pi. Cos, basically it's always going to be the opposite of sine. It's going to start at 1, it's going to hit 0 when sine is 1, and I've got some graphics on my website that kind of show what that looks like. In any case, all we need to know is that our baseline amplitude, how high our wave is from the midpoint to the max or the min, that's our amplitude. And then our period is how long does it take for our wave to do one full rotation where it hits a max, hits a min, and gets back to its starting point, okay? And that baseline is 2 pi, just like in our circle. One full rotation is 2 pi, okay? So now we can start messing around with our amplitude and our period. We can start stretching our wave vertically by changing the amplitude, or we can compress it. They're function transformations. They're the exact same thing we've done with, with every other function we've looked at, radicals, logarithms, everything. So, but first we're going to learn just a little bit about amplitude and period. So, like I said, I'm going to use colors to coordinate between sine and cos for now. So, no, I'm not. I'm going to use black. So let's deal with amplitude first. Let's say I have my wave, and my wave is y is equal to sine x. Okay? If I wanted to double the size of my wave, okay, I'm going to play with my amplitude A. And my amplitude A lives in front of sine. Then the baseline amplitude is 1. So what if I said y is equal to 2 sine x? Well, basically all I'm doing is now my amplitude is 2. So the distance from the middle of my wave to a peak is 2. So if I was to redraw the sine wave, I'd have to start drawing it now going all the way up to 2, coming down, maxing out at -2, coming up, right? It's still going to be 0 at the same places, but it's just going to be stretched in everywhere else. And I could do the same thing. So say I did something to cos now. What if if I put a half here, if I said y is equal to half sine x, all I'm doing is going to be halving my graph. So what if I did y is equal to 1 over 3 cos x? Well, now I'm going to be taking my amplitude, which is 1, and I'm going to be dividing it by 3. I'm going to be thirding it. So if I was to redraw my cos, it would start at 1/3 of 1. It would still 0 out at the same places, but it would be 1/3 the amplitude and everywhere else. Okay, so let me draw a 1/3 cos of x for my best guess at what that would look like. So it's going to be coming down, zeroing out at the same place, zeroing out there, and like that. Okay, that's what a 1/3 cos x would ish look like. I think that's pretty straightforward. That's not like a crazy concept to determine. And if they gave us a graph that looked like, if they gave us a graph that looked like this, and this was 2 pi, so a full rotation. Sorry, this was 2 pi over here to represent one full rotation. And let's say this was 4 here and minus 4 here. You would know that you could just go my max minus my minimum divided by 2 to get my amplitude, which would be 4. And that should be in red because amplitude is 4. So that's how we deal with amplitude. Super straightforward. Okay. Now period, basically the length of my graph, my sinusoidal wave, it's going to be the b. And so period lives right here. Okay? So my baseline period is 1, or is 2 pi, okay? So if I have y is equal to sine x, there's nothing in front of my x except for 1, so I assume that I'm at my baseline period of 2 pi. Now, just like in every other transformation we've dealt with b is a reciprocal, it plays reciprocally, okay? So what I do, say I had y is equal to sine of 4x here, sine of 4x, okay? To figure out my period, I just take, my period is equal to a full rotation or a full period, which is 2 pi, divided by the absolute value of b. And that's going to give me my new period. So in this case, if I had sine of 4x, it'd be 2 pi divided by 4, or my new period is pi over 2. And I could use, instead of 2 pi, I could use 360 as well. 360 degrees, if I wanted to work with degrees, divided by 4 is 90. So my new period is 90 degrees or pi over 2, which means that my new period for this one, sine of x, will have done an entire full cycle by the time it gets there, okay? And all things being the same, that new graph would look something like this. Okay? It's going to hit a maximum and go back to normal with an amplitude of 1. So it's going to hit positive 1, negative 1 in the span of pi over 2, because that's my period. That's how long it takes to do a full cycle. And I mean, if I were to keep kind of going on with this one, it would just keep doing the same thing. Every pi over 2, it would be a full rotation. So that's what amplitude does, or sorry, that's what period does. So if I gave us something like y is equal to cos of 0.5x, well then to figure out what this period is going to represent, I'm going to go 2 pi divided by the absolute value of b, which is 0.5, and it's going to give me 4 pi. So my new period for this function would actually be a stretch, where at one full rotation, it's going to take double the time. So it's only gone halfway by the time we get to 2 pi. It's going to take 4 pi to finish the cycle. So that's how the period works. So if say that they asked us to, say they said, okay, you have a sinusoidal wave that has an amplitude of 2 and a period of, pi. Okay, and it says what would the equation for that graph be? So, and it's y is equal to sine of x based on that, okay? So the first thing you know is if my amplitude is 2, then my a is 2. That's nice and easy and straightforward. So a is equal to 2. My period is equal to 2 pi divided by the absolute value of b. Now I want to figure out what b gives me this period. So I'm just going to solve for b in this equation. I'm just going to switch it out. So the absolute value of b is actually equal to 2 pi divided by my period, which is 2 pi divided by pi. The pi's cancel. B is equal to 2. is equal to 2. Therefore, I can go right ahead and write my new equation for this wave with these properties as y is equal to 2 sine equal to 2 sine of 2x. And if I were to graph this guy, okay, if I were to graph this guy, well, first thing I know is it's going to have a peak of 2 and a minimum of -2, right? Because it's got an amplitude of 2. And it's going to have a period of pi, so it's going to make a full rotation by the time it hits pi. It's going to have a full cycle by the time it hits the halfway point to 2 pi. So therefore, it's going to go whoa, then it's going to come down, whoa, all the way to -2, and it's going to come right back there. And it's just going to keep doing that cycle all forever and ever and ever on both sides, right? So that's what that looks like. And hopefully that's enough to get us going here. So, oh shoot. That's for now. We're going to move on now. In the next phase, we're going to talk about all the transformations. So we're going to add K and we're going to add H, which are called phase shifts and I don't know the word yet. I'll know it for the next video. Bye.